consideration we have for enterprise wireless networks is client density. Client density refers to the number of clients we need to service within a particular wireless coverage area, and it's an inverse relationship between the number of clients that we can serve and the possible network performance for each of those clients. Here in this example, we just have 3 clients, and they get to share the resources of that wireless access point. But as we start to add different devices to that access point, then the slice of the bandwidth pie available to each wireless client is going to decrease. And let's say that we do need to increase our client density, because today we might have one user that's using multiple wireless connections simultaneously. They might walk into their office carrying a smartphone, which is going to be connecting to the wireless access point. They might have a smart watch that connects to that access point. They might be carrying their laptop and a tablet, each of which can connect to that wireless access point. So it's a lot easier to have a higher client density in today's networks. And as we're thinking about client density, we need to keep in mind overlapping channels. Here we have one access point, and it's using a particular channel, and it has this coverage area that you see highlighted. But if we need a higher client density, and we start installing other access points in close proximity to the first access point, they're all going to be using part of our available radio spectrum as well, and hopefully they're using non-overlapping channels to avoid interference, but we only have so many non-overlapping channels available to us. We only have 3 in the 2.4 gigahertz range. We have more if we're using the 5 gigahertz range, or even more if we're using the 6 gigahertz range. And if we do have our access points physically packed tightly together like this, and we might be using some overlapping channels, one option to still give us the performance of multiple access points while avoiding overlapping channels is to reduce the signal strength where one access point is not interfering with another access point. And when we're selecting the number of access points to use in a network, we need to consider the specifications of the AP we're selecting. Things are going to vary widely depending on the specific model of AP. One AP may have more radios than another AP. They may support different wireless standards. For example, we can have more non-overlapping channels using the 6 gigahertz band offered by Wi-Fi 6E as compared to Wi-Fi 6. Of course, that's assuming our clients can support Wi-Fi 6E. Another factor that impacts our client density is the anticipated number of simultaneous communication streams that we need to support. Is it a classroom where everybody is going to be active at one time going to a particular website that the professor is lecturing about? And what are the bandwidth demands of a particular application? Is it text-based, or is everybody streaming 8K video? And in a particular design, if you decide that you do need to increase the number of APs, what can you do? Well, you can increase the number of APs physically, and to help prevent one AP from interfering with another AP, you can reduce the transmit power of those APs. And if you're still running into an overlapping channel issue, something else you might consider is your channel bonding. For example, let's say that instead of using a single channel that's 160 megahertz in width, which is bonded together 8 20 megahertz channels, what if you broke that down to 4 40 megahertz channels? That would allow 4 different access points to use separate 40 megahertz channels, where before we had just one access point using one 160 megahertz channel. And as I hinted at earlier, if your clients support it, you might consider using Wi-Fi 6E, which adds on to the Wi-Fi 6 standard by allowing you to use the 6 gigahertz band, giving you an even wider range of non-overlapping channels. And that's a look at a few design considerations regarding client density for our enterprise wireless networks.